So let's integrate this. If we use the fundamental theorem of calculus to integrate this, this is a parabola turned upside down. So it has a y intercept of +4, right? And then it's parabola with a leading coefficient of -1. So it kind of does this thing. And then we want to evaluate it from 0 to 2. So I'm not quite sure where that will put us. Probably if we go from 0 to 2. Oh, it wanted us to do from 0 to... Wait. Oh, it wanted us to go 0 to 3. Okay, that makes more sense.
What was that sound?
0 to 3 real quick. Ha ha ha. Yeah, I'm Drake. So here we go. Here's the problem. If I go 1, 2, 3, I'm going to have... Shh, settle down. I'm going to have an area under the curve here and an area under the curve here. Now this is going to be positive, mathematically speaking. This is going to be negative, right? I don't know, well, I don't know what the exact value is, but it's going to be negative. And so let me read this. It says, find the area of the region under the curve. Okay? And then what it wants us to do is it wants us, if I do this on the calculator, I look at it and go, oh yeah, I know what I'm doing. I go into my calculator and I graph the function and I say 4 minus x squared, right? I graph it. There it is. And then I'm going to integrate it, find the area under the curve from 0 to 3. All right, I get 3 as my answer. But like I said, this stuff over here is negative. Well, depending on the application, I may just want the area, right? So this equation might represent the amount of fabric I need for a certain amount of t-shirts that I'm going to make. And I get a negative area, but I might want to include that area. But if I were just to use my calculator, right now my area is 3. But it's not 3. Actually, my area under the curve, if I recalculate this, if I go from 0, and it looks like it crosses at about 2. I'm not quite sure where it crosses. But if you notice from 0 to 2, it's 5.33. Right? And then if you go from 2 to 3, it'll be a negative number. So if I go calculate the area under the curve by hitting second calc, and I go from 2 to 3, I get a negative 2.3. So if I were just interested in the actual area, it looks like it's like 7 2/3 or some funny number like that. So how would I solve that if I just wanted to know the absolute area? Not the mathematical value, but the absolute area. What I need to do is I need to figure out where this thing crosses the x-axis. Now your textbook just kind of approximates where it crosses the x-axis, but I don't really want to just approximate it. Actually, no, it should cross it too. Did I plug that in correctly? Yeah, I plugged it in correctly. Let's trace it and see if I plug in 2. Yeah, that's right. So it crosses at 2. So now how do I do that? Well, remember one of the properties, we could do it on by hand on the calculator, but we said that I could break this up. In other words, this integration is equal to 0 to 2 of 4 minus x squared dx plus 2 to 3 4 minus x squared dx. But the only trick here is that I want to know the absolute value of the area. So I could say, let's figure out what the absolute value of this is and the absolute value of what this is. Those are absolute value brackets. All right, so I got to do 4 integrations. So using the fundamental theorem of calculus, I'm going to take the antiderivative of this. And so I'm going to say 4x minus x cubed over 3 evaluated from 0 to 2, and I want to take that absolute value of that and add that to the absolute value of the same thing, 4x minus x to the third all over 3 evaluated from 2 to 3. Okay? So now if I go up here, I'm going to get, because of the 0 will cancel. So I'm going to get 4 times 2 minus 2 to the third all over 3 minus, well, 0, right? Because if I plug the 0 in here and the 0 in here, I get 0. So I need the absolute value of that. Over here, I'm going to do the same thing. Let me make sure that I do it the right way. So this is supposed to be 4 thirds minus 3 thirds over 3, right? Minus, okay, 4 times 2 minus 2 thirds, like that. Really, you get like 12 minus 9 here, minus 16 thirds. So this becomes 3 minus that. So then down here, we get 9 thirds minus 16 thirds. This whole thing becomes negative 7 thirds. And so when we get down to the bottom here, because we're adding the absolute value, it becomes 7 thirds, which is 23 thirds, which is, what is that, 7 and 2 thirds? Or 7 and 1 third? 7 and 2 thirds. Right? Or 23 thirds. Does that make sense? And you gotta be careful, because even if I made that mistake, like that's a typical mistake that somebody would make on a calculus, AP Calc exam. So despite Mr. Adams' little mistake, does that make sense to you guys? Do you guys have any questions?